Rahim. I am Mr. Muhammad Hassan Chattha, Assistant Professor, Government Degree College Chichawatni. Dear student dear student of the third year and fourth year of the physical chemistry, let us learn about the Ostwald distribution law. Ostwald distribution law, according to the Arrhenius theory of the dissociation, an electrolyte dissociate into ions in water solution. These ions are in state of equilibrium with undissociated ion. This equilibrium is known as ionic equilibrium. Ostwald noted that law of mass action can be applied to ionic equilibrium as in case of chemical equilibrium. Let us consider a binary electrolyte AB which dissociate into the solution to form A positive ion and B negative ion. AB dissociate into A positive ion and B negative ion. Let C mole per liter the concentration of electrolyte and alpha is the degree of dissociation. The concentration at equilibrium is written as the concentration of AB is equal to C multiply 1 minus alpha mole per liter. Similarly, concentration of the A positive ion C alpha mole per liter and concentration of B C alpha mole per liter. Applying the law of mass action, rate of dissociation is Ka multiplied by the concentration of the AB yani C multiplied by 1 minus alpha. Rate of combination K2 multiplied by C alpha into C alpha. So the rate of the dissociation is the forward action, rate of combination is the rate of the backward action. So we have just placed the value of the ion dissociation ions. Dear student, if we have at equilibriums, to the concentrations rate constant K1 into C multiplied by 1 minus alpha is equal to K multiplied by C alpha and again multiplied by C alpha. These are equated. Then we get the two constant ratio K1 over K2 is equal to Kc rate constant, and above we get the C alpha square, and in denominator 1 minus alpha mole per liter, it is the equilibrium constant. It's known as dissociation constant or ionization constant. You have at certain constant temperature. If 1 mole of electrolyte is dissolved in V liter of the solution, then C is equal to 1 over V is known as dilution, and the law expression become is equal to Kc is equal to degree of dissociation square alpha square 1 minus alpha and into multiply by volumes. This expression, which correlate the variation of the degree of dissociation with dilution, is known as Ostwald-dilution law. For weak electrolyte, the values of alpha is very small as compared to you have 1. So in most calculation we can take 1 minus alpha is approximately equal to 1. Thus Ostwald dilution law expression become only Kc is equal to alpha square over V. It implies the degree of dissociation of weak electrolyte is proportional to square root of the dilution. It implies, and it means that degree of dissociation of the weak electrolyte is proportional to the square root of the its dilution, For strong electrolyte, the value of alpha is large, it cannot be neglected in comparison with 1. Thus we have the original expression Kc is equal to alpha square 1 minus alpha V, or alpha square is equal to Kc V minus alpha Kc V. So it gives the equation alpha square plus alpha Kc V minus Kc V is equal to 0. From the equation, alpha can be evaluated. Experimental verification of the Ostwald-dilution law. Ostwald-dilution law can be verified if the value of the alpha and degree of dissociation at different dilutions are known. The value of alpha is determined experimentally by using relation alpha is equal to equivalent conduction at dilution V and infinite dilution respectively, lambda V and lambda infinite, and represented by the lambda V and lambda infinite. Their value are found by conduction measurement, and Kohlrausch law, the value of alpha at various dilution thus determined are inserted in this expression to get Kc is equal to alpha square 1 minus alpha multiplied by V, where K is the constant and in the Ostwald law hence verified. In case of limitation of the Ostwald dilution law, the law is based on Arrhenius theory, which assumes that only fraction of the molecules dissociated in at ordinary dilution, complete dissociation occur only at infinite dilution. However, this is true for weak electrolyte. Strong electrolyte are almost not completely ionized, so they are not obey the dissociation law, Ostwald law. Ostwald law is derived the assumptions law of mass actions holds for the chemical equilibrium, ionic equilibriums, but when the concentration of the ion is very high, presence of the charges affect the equilibrium. Thus, the law of mass action is simply form cannot be employed. Simple form of law of mass action cannot be employed here. Ion obtained by the dissociations may get hydrated, may affect the concentrations term, but better results are obtained by using the activities instead of using the concentration. So these are the three limitations in the Ostwald dilution laws. Thank you, student. Allah Hafiz.